anyone who wanted to go to college in America had the option of taking the ACT. Now, for those of you who've never taken the ACT, it is sort of like the SAT, except that instead of having different sections repeat, you first do one section, which is, I believe, writing or reading first, then you do math, then you do writing, then you do science. So they don't have sections overlap. So once you're done with one section, you're done with a section. That being said, though, the science section was the bane of many people's existence because the science section on the ACT was not actually testing for your science knowledge. Those of us who took it were told it was more like reading comprehension, but with the science bent. The unfortunate part was that's not exactly true either. It wasn't until today, when I was trying to make comparisons to tax law, that I looked at the ACT science section again and I realized, oh, there's actually more in common with the concept of blinders that I've been showing you guys. Now, if you watched the previous video, which I'm going to put here, you're going to know that the SAT reading comprehension sections where you read the passages and answer questions are actually the most like tax law. But the science section on the ACT is almost a step away from that. And that's what I wanted to show you today. And I'm going to introduce the concept of limited blinders. If you haven't watched my first video exploring blinders, watch it here. What blinders are, it's basically, imagine you took out everything you know, all the biases, all the assumptions, and you only interpret the text. If the text says it, it means there's something to it. If the text doesn't say it, then you look for evidence elsewhere. And if it still doesn't say it, then doesn't say it. So that's what blinders is. It's basically you only look at what's presented. Now, that's what I thought the ACT science section was, but actually it's not that simple. So to illustrate, let's go to a practice problem. I just randomly did these practice problems for fun just to see if my interpretation nowadays was correct. When I took the ACT, all I can say is I did worse on the science section than all the other sections. On the writing section on the ACT, I got 33 out of 36. On the reading section, I got 32 out of 36. On the math section, I got 35 out of 36. And the science section, it was either 29 or 30. I forgot. You see, there's a big difference between how I did on science versus the other sections. Like many people, I was weakest in the science section. So I was really surprised when I did these practice problems today for fun that I got them all right. So let me show you my thought process, and then let's kind of apply what I've been learning in tax law and how it sort of can apply and help you with the science section. So first thing to know is if this gives you any anxiety, gives you any PTSD, trust me, I got it too. I was in the coffee shop and I'm like, wow, this coffee shop's not calming me. This is actually making me really anxious. But for the sake of exploring knowledge, for the sake of making sense of the world, I did this. For those of you who've never taken the science portion of the ACT, it's like the reading comprehension section of the SAT, but the difference is oftentimes there's competing claims that you have to analyze, or it's experimental design you have to analyze. So it's a next layer of reading comprehension. So this one's about Europa. Unmanned spacecraft taking images of Jupiter's moon Europa have found its surface to be very smooth with few meteorite craters. Europa's surface ice shows evidence of being continually re-smoothed and reshaped. Cracks, dark bands, and pressure ridges created when water or slush is squeezed between two slabs of ice are commonly seen in images of the surface. Two scientists expressed their views as to whether the presence of a deep ocean beneath the surface is responsible for Europa's surface features. So that was just kind of a little overview of what the debate is about, right? And here's scientist one. A deep ocean of liquid water exists on Europa. Jupiter's gravitational field produces tides within Europa that can cause heating of the subsurface to a point where liquid water can exist. The numerous cracks and dark bands in the surface ice closely resemble the appearance of thawing ice covering the polar oceans on Earth. Only a substantial amount of circulating liquid water can crack and rotate such large slabs of ice. The few meteorite craters that exist are shallow and have been smoothed by liquid water that oozed up into the crater from the subsurface and then quickly froze. Jupiter's magnetic field sweeping past Europa would interact with the salty deep ocean and produce a second magnetic field around Europa. The spacecraft has found evidence of this second magnetic field. Scientist 2. No deep liquid water ocean exists on Europa. The heat generated by gravitational tides is quickly lost to space because of Europa's small size, as shown by its very low surface temperature, minus 160 degrees Celsius. Many of the features on Europa's surface resemble features created by flowing glaciers on Earth. Large amounts of liquid water are not required for the creation of these features. If a thin layer of ice below the surface is much warmer than the surface ice, it may be able to flow and cause cracking and movement of the surface ice. Few meteorite craters are observed because of Europa's very thin atmosphere. Surface ice continually sublimes, changes from solid to gas into this atmosphere, quickly eroding and removing any craters that may have formed. So for those of you who just sat through all that, you could understand why at first I thought, okay, tax law, learning and reading and interpreting tax law is a lot like the science section of ACT. It's a lot of terms, right? A lot of technical terms, and you just have to not get lost and intimidated by the technical terms. So far I thought of my comparison as correct, but then I looked at the questions that were asked, and then I realized, okay, my comparison is not exactly correct. So let's look at the questions now. So let's look at question 1. Which of the following best describes how the two scientists explain how craters are removed from Europa's surface? So this is a generalized understanding question, right? So you had to understand what scientist 1's central argument is, and then you had to understand what scientist 2's central argument is. So let's look at the answer choices. Scientist 1, sublimation. Scientist 2, filled by water. Scientist 1, filled by water. Scientist 2, sublimation. Scientist 1, warmed by wind. Scientist 2, sublimation. Scientist 1, warmed by wind. Scientist 2, filled by water. So we obviously can eliminate these two, right? Because think about it. I don't see anything about wind. In fact, all we see is that Europa has either no atmosphere or light atmosphere. So at the end of the day, it's probably down to A to B. So unfortunately, part of what's so stressful about doing these, especially under time crunch, is you got to go back and confirm some things. That's part of what I call the blinders. You got to make sure it was mentioned. Let's very briefly look at Scientist 1, right? Scientist 1 talked about a magnetic field. He talked about ocean liquid. Okay, I don't see anything about sublimation, but I do remember Scientist 2 talked about sublimation, right? The word sublimes, you have to know that sublimes is the verb. I always said sublimate when I was in high school, but sublimes is actually the verb, right? You got to pull that from chemistry, biology, etc. You got to know that directly changing from solid to gas is sublimation. So this is an example of you do have to bring in something from outside. It's not complete blinders because you have to bring in certain science knowledge from the outside. You see, that's when I realized, okay, this is not the right comparison. Shout out my friends Jordan and Chris. I was telling them about this. After I did these problems, I sent them an email immediately. I told them, I said, okay, I see this is not exactly the same because it does require basic science knowledge. So obviously you still have to apply blinders, as in you have to find it supported in the passage, but still some of these questions are meant to bring in other knowledge. So this is where limited blinders applies. Maybe we should call it bounded blinders. That's very alliterative. Bounded blinders. We could basically pick B, but sometimes you want to make sure, right? So let's go back. Let's go to Scientist 2 again. Again, he says there's no deep liquid ocean. And then he mentions here, few meteorite craters are observed because of Europa's very thin atmosphere. Surface ice continually sublimes into this atmosphere, quickly eroding and removing any craters that may have formed. So he seems to advocate sublimation. And then filled by water. Again, at this point, through process of elimination, we've already decided on B. And if we were taking the test, we would probably just move on. But because I'm trying to apply what I've learned from tax law, then let's just quickly apply the bounded blinders. I love that word, bounded blinders, to look at passage 1 again. So let's look at Scientist 1. He's talking about deep ocean water, right? Cracks and resemble the appearance of thawing ice. Only a substantial amount of circulating liquid water can crack and rotate such large slabs of ice, right? And then the few meteorite craters are shallow, have been smoothed by liquid water that oozed up into the crater from the subsurface and then quickly froze. Again, that seems to filled in by water, right? So I think we have ample evidence, bounded blinders again. The passage supports this. So let's go to the next one. According to the information provided, which of the following descriptions of Europa would be accepted by both scientists? Again, this requires a correct interpretation of both of their arguments and also a comparison and contrast, right? So this is another logical step. So Europa has a larger diameter than does Jupiter. Again, we know from Europa that it doesn't, but when we look at these questions, we have to see if the scientists actually talk about it, right? That's the part about blinders. Do the two scientists talk about Europa being as big as Jupiter? I don't think so. And again, if you were taking this test, you would probably take a quick look back just to make sure, but this definitely does not resemble anything we read. Europa has a surface made of rocky material. Again, this is one of those things that there is no evidence from either scientist of talking about rocky material. So we can very quickly eliminate that one. Europa has a surface temperature of 20 degrees Celsius. Now, we did see that mentioned. Actually, we didn't. Never mind. See, we did see something mentioned that was temperature-wise, but eliminate this one. And then Europa is completely covered by a thin layer of ice. I think both scientists have talked about this. Central to the debate is why it's so smooth, right? But both of them have this assumption that there's a layer of ice. In fact, layer of ice. Notice I actually read thin because one of the scientists said thin, but the other one didn't. So this is now confirmed. Central to this argument in the science passage is what is going on with the ice in Europa. So now we go to this question. With which of the following statements about the conditions on Europa or the evolution of Europa's surface would both scientists 1 and scientists 2 most likely agree? This is another comparison and contrast. The surface of Europa is being shaped by the movement of ice, is covered with millions of meteorite craters. Now, we definitely can eliminate this one. Is the same temperature as the surface of the Arctic Ocean on Earth. Okay, this is definitely eliminated. Has remained unchanged for millions of years. See, this one might look promising, but then if you quickly go back and read, so much of what they're arguing is the fact that there's processes within Europa that are changing it. So it seems like this is something that both of them would agree on. If you were doing this, you would quickly look back again to make sure that there's evidence in the passages. Let's say we look back, we're looking at, they're talking about oceans, they're talking about ice, they're talking about magnetic fields, and then see, they're also talking about ice here, right? So it seems like there is something that they agree on here. Which of the following statements about meteorite craters on Europa would be most consistent with both scientists' view? So this is another logical leap, right? Because this one is, okay, you have to understand both of the scientists and now apply them both in comparison to another statement. So no meteorites have struck Europa for millions of years. That's definitely something they both would not agree with because they're arguing about why we don't see evidence of meteorites hitting all the time. But it doesn't mean they don't think that meteorites hit. So meteorite craters, once formed, are then smoothed or removed by Europa's surface processes. This one looks promising. Meteor craters, once formed on Europa, remain unchanged for billions of years. We can definitely eliminate this, right? Because again, the argument's all about what's getting rid of those meteorite craters. Meteorites frequently strike Europa's surface, but do not leave any craters. Again, there's nothing in the passage to support this. First of all, both scientists don't mention how frequently. So this already is moot, but also do not leave any craters. There's a reading comprehension moment here. Do not leave any craters, as in the meteorites immediately do not leave any craters, or the processes on Europa cause the meteorites to not leave any craters, right? But the most important thing is this frequently. And again, we can look back and is there anything here that talks about frequent? Few meteorite craters that exist are shallow. Anything about frequent? We can look at right here, evidence being continually reshaped. We don't see anything about frequent meteorite. So we can eliminate that through process of elimination. You see, there's so much process of elimination, right? Meteorite craters, once formed, the smooth are removed by Europa's surface processes. Scientist 2 explains that ice sublimes to water vapor and enters Europa's atmosphere. If ultraviolet light then broke those water vapor molecules, which of the following gases would one most likely expect to find in Europa's atmosphere as a result of this process? What is water, right? Water is H2O, so if it's broken apart, you would get oxygen. See, that's another example. That's an example how it's different from tax law. Like in tax law, you don't have to bring in some kind of that knowledge. But in the science section of the ACT, you have to know from basic biology that water is H2O, 2 hydrogen atoms and 1 oxygen atom. So when I was doing that problem, I was like, okay, this is a big difference. This is an example of bounded blinders. You have to know that water is H2O, but then you can't make any assumptions beyond that. You look at the passage and you look at the question and you answer it thoroughly. You can't carry any more biases of what you think Europa is, what UV light does to water, etc., etc. You just accept and you interpret based on what the passage says. But you have to know that water is H2O. Based on the information in Scientist 1's view, which of the following materials must be present on Europa if a magnetic field is to be generated on Europa? When I first read this, I distinctly remember him mentioning this. So sometimes you don't even need to look at the answer choices. You could just go back to the passage if you really remember it. He said right here, Jupiter's magnetic field sweeping past Europa would interact with the salty deep ocean and produce a second magnetic field around Europa. So salty, right? So let's look at this. Frozen nitrogen, that's not a salt. Water, ice, that's not a salt. Hey, dissolved salts, right? This one I think was the easiest one because this one was just a direct recall. Last one. Assume Scientist 2's view about the similarities between Europa's surface features and flowing glaciers on Earth is correct. So this one again, blinders, right? Assume he's correct. Based on this assumption and the information provided, Earth's glaciers would be least likely, notice the tricky phrasing, Earth's glaciers would be least likely to exhibit which of the following features. So this requires you to understand Scientist 2's views, then you put on blinders, then you understand what least likely means, and then you look at this. So let's go back to Scientist 2 view about the glaciers on Earth, right here. Many of the features of Europa's surface resemble features created by flowing glaciers on Earth. Large amounts of liquid water are not required for the creation of these features. If a thin layer of ice below the surface is much warmer than the surface ice, it may be able to flow and cause cracking and movement of the surface ice. Okay, so this is what he believes about Earth's glaciers. Okay, so let's go down here. Earth's glaciers would least likely exhibit which of the following? Okay. Pressure ridges, cracks, dark bands, or meteorite craters. So there's no mention of pressure ridges. So this is a blinders moment. Did he talk about pressure ridges? From the passage we read about him, he didn't talk about this. He did mention cracks, right? He did mention that cracks often is how flow of whatever process occurs. So this one is not least likely. In fact, this might be a most likely. Now, did he talk about dark bands? He didn't talk about dark bands. So again, this is a hard question. If you put on your bounded blinders and then understand what Scientist 2 is talking about, this is the answer. He's arguing all these processes that prevent meteorite craters from showing up on Europa. And if Europa's process is very similar to the glaciers on Earth, then you're going to likely see something similar. So if meteorite craters happen to the glaciers on Earth, then they would also be covered up very quickly. Okay, so let's look at the answers. Notice it gives you feedback immediately, right? So I remember when I first did this, I was like, oh my God, what if I get them all wrong? But see, got this right. It's cool to kind of explain all this to you guys, like my thought process, right? I mean, this is how you get better at things, right? And see, look at this. Dissolved salts. Yeah, I got it all right. Meteorite craters. Yeah, exactly. So there you go. If I knew this was the process, the thought process, the method behind taking the ACT science section, I probably would have aced it, man. So for anyone that felt lost, whether when you took the ACT or even now, I hope what this shows you, a lot of these test prep books, a lot of these test prep teachers, they really don't know what they're doing. Why didn't they explain it to me like how I'm explaining it to you? Now, obviously everyone's learning style is different, but for certain things, there's a certain learning style that's more effective. And once I adopted what I called the bounded, I can't say that word anymore. The bounded blinders. Man, I created my own cool phrase and then I can't even remember it. And once I adopted the bounded blinders little mentality, I was able to do this section on the ACT that I always had trouble with when I was doing test prep back in the day. So beyond thinking about, okay, how do you teach the section better? Let's step back even more. What the heck is this section for? Maybe you should explain to people why they should even prepare for this section. For example, what fields might need what I call bounded blinders? And then like we talked about in the last video, if you're a guy who does really well in this section, what fields could you really be effective in? Now, those questions I don't have the answer for, so I look forward to your comments. Because obviously, I just today make a comparison to tax law that wasn't even completely correct. I figured out how to take the ACT science section. It's kind of amazing how life works. So I'm totally just riding this epiphany now and just thinking about it and passing it on to you. We all know that these tests, these standardized tests, are supposed to correlate to certain things. And it wasn't communicated to most of us when we were trying to prepare for them. And I think even till this day, with all the internet and all the knowledge and all the forefathers before us, it still isn't communicated well what they're trying to measure and what you can do if you either score well or don't score well. And I want to end off this video by giving a big shout out to Ms. Gates. Ms. Gates was my English teacher for 2 years in high school. She was a very forward-thinking educator who I think she would have really appreciated this video, so I'm going to show this to her. But she also really believed in me as a student. So I really thank Ms. Gates all these years. There are maybe 2 teachers I can really think of in high school who really believed in me. One was kind of a family friend, so obviously, right, because she knew of me outside of school. But Miss Gates didn't know of me outside of school. Miss Gates just really believed in me, and she was always there when needed. Man, Miss Gates, I think about the teachers that really had a good influence in my life, and I really thank Miss Gates. So Miss Gates, shout out to you. I hope you enjoyed this video. But to everyone else studying test prep, studying education, just studying, or just in general thinking about stuff, I hope this video gives you things to think about. And to the people who run the ACT, if you see this, I will look forward to your comment too. What is your purpose of designing the science section for the ACT? Okay, guys, talk to you soon.